There comes a time when we all have to think about what we spend most of our time thinking about. And obviously for all of us, it's boats or rafts which you can tow behind you, and you can cool drinks in the heat of summer with batteries. Okay, maybe not. But before we get started and we talk about this ridiculous endeavor, let's do a bit of cleanup, because this bench is in no state to be used as a precision manufacturing instrument to make such a glorious achievement. Good. Now that's out the way. Why would you want this cooler boat device? Well, the truth is that I've seen a lot of videos with using Peltier devices to cool water bottles magically, or to make water out of thin air, which don't work because Peltier devices, these things, are traditionally very inefficient. They require a lot of power to do relatively a little amounts of cooling or heating in that case, but they heat much better than they cool. Despite their drawbacks, I have a lot of batteries which are from quadcopter flying, which no longer are strong enough to deliver all the current which I need for the mini quad stuff, but still have their full capacity at a lower rate. So the idea is as follows. This is the cold side. Imagine this was bigger. This is the base which I will eventually use, maybe if it all works out, but this is the base. But imagine making bigger walls here out of some kind of flotation device, or at least attaching this to some kind of flotation device and making a shape of a boat. So you make this area much larger, but this is the active cooling area, and these heat sinks here radiate the coolness into the surrounding water, so they dissipate their cold and they cool the water, and you would put all your drinks inside here. You stack them up inside the area. I'd say about that much water. That's why I've sealed them all off with silicone, so that the water doesn't actually get to the Peltier device. It just surrounds only the heat sink is actually touching the water. All these wires will obviously be insulated as well. The trick about Peltier devices is if you let the hot side cool, in Entschuldigung, if you let the hot side get too hot, then they lose their efficiency and they stop working, and eventually they will actually break if you would just leave them running in open air. So the cooler you can keep the hot side, the cooler the cool side will get. On the flip side, I have the bottoms of this, and this is what will be in contact with the lake. Now, the lake, the river, the water, the body of water, which is significantly bigger than a bathtub. If you can dissipate a lot of heat away from the devices, then you can make a lot more cooling effect on the top side. And what I'm thinking is this will be in contact with the water permanently. They're all perfectly sealed now. I had some problems where water was leaking through, which is probably why I ended up with broken devices. But I've replaced them since, and now there is one, there is one, there is one, there is one, there is one. There are 3 here, there are 2 here. This will be in the water on the bottom, and water was a great conductor of heat, so it will be able to wick away a lot of the heat generated by these things. So the next step would be to calculate how much power we actually need. I'm thinking of running these on a 4-cell LiPo battery, because I've got lots of them. These are nominally 14 volts. When they're fully charged, they're about 16. So these are rated at 12 volts, or between 10 and 12 max. I'm thinking running them at half power, so 2 of them in series to, let's say, 1 battery, but it'll be a bank of batteries. So I series, I series, I series, I series, and I series, and then I run those in parallel to give each Peltier device round about 7 to 8, 9, no, not 9, 8, 7, 6.5 volts at a lot of current, as much as they need. They can draw up to 4 amps, but I think that's a lot. and then we can see how much they cool and how much power they draw. Now, power isn't really a concern. As I said, I've got a lot of batteries, so I don't need to worry about being efficient, because generally this is not an efficient setup. I would obviously have to cover the whole top of the boat with some kind of an insulating zip type thing that you could put your drinks in, and then you plug it in, and then the water gets cold, and then I heat up the lake, because the swimmers will eventually thank me anyway when the lake is a little bit warmer. Good. So what we're going to do next is we're going to connect up one of these devices to a 4-cell battery, which is about half charge, and we're going to see how much current it draws, drawing the most it can with, you know, nothing limiting it besides this thin wire here. So what I've got here is a plus, which goes into a plus of this parallel port, so I can connect many batteries at once. Let's go and grab one of the batteries. I'm going to just plug that in now. There we go. Then I'm going to take the plus from here, and I'm going to connect it to the minus from the Peltier device. I'm going to take the minus from the multimeter and hook it up to the plus or minus of the battery. And what we see here is, there we go, 1.8 amps at whatever current it's, whatever voltage we have here. And as a little measurement, let's check room temperature in here is 23 degrees. And you can really see this device is down to 18.8, 18.0, so it's dropping. And if I feel the bottom, it's getting warm fast. So 1.8 amps. So the battery is 14.97 volts, and it's drawing 1.7 amps, so that's 25 watts per Peltier device. The bottom's getting warm-ish. No, it's getting quite warm. And the top is now, well, it's no colder. No, it's colder. I can feel it's colder, but the aluminium doesn't allow you to measure it so well. But the bottom is now at 23. No, it's warmer. Must be warmer. 37 degrees. There we go. Good. So you see that the top isn't as cold as the bottom is hot. And this is the trick why I would submerge the whole thing in water. The top in the cold water for your drinks, the bottom in the lake water, but to dissipate the heat. And what we'll do next is we will parallel up, or series up sets of 2, and then parallel those up and then connect them to a bigger battery bank, and then we'll see how much cooling effect we can actually get out of this thing. So let's see that.